Hello, everyone. Welcome to the class. So today we're going to go over, this is the last stretch of the semester, right? We're getting pretty close to the end here. Today I'll go over the calendar just to kind of give you a big picture of what we have left. And then we have a topic, a main topic for this week, which is called Snmp as a protocol. Has existed for a while, related to system administration, basically. So it's the most associated protocol with sysadmin. So we'll go over that today. So let's start with the calendar. I need to share this. Also, I probably need to. Oh, it's recording already. So it's recording. So let's go ahead to look at the calendar here. All right, and so we are this class, sysadmin. Let me just refresh here. Okay, so we are back from spring break. This will be more or less the sequence that we have left for the semester. Notice final exams, make a note of this, will be the week of May 2nd, May 3rd. So this class meets on Tuesday, so the exam will probably be Tuesday. Probably, I think it's usually 2:45 to 4:45, something like that in the afternoon. It'll be a virtual exam, so we don't need to meet. I will be out of town, actually, so you need to take the exam that way. You should be done with everything by that day. If you look this week, April 26th and April 28th will be what? Presentations. Make a note of that. You have Project A and Project B, right? Project A is configuring Hadoop on Linux, right? Remember I've said if you had trouble configuring DNS, well, multiply that times a lot more, exponentially probably. And that's how difficult Hadoop is. Okay, so you need to, that's why it's your term project. It's worth 5% of your grade, but also if you can do that, you can do anything in Linux, right? So that's kind of the way that you should see it as a practical type of a proof for yourself. Remember what I said in the lecture, start with single node, and then do multi-node. Single node is a lot easier than multi-node, okay? So definitely make a note of that. You will do your demos on this week. So basically I'll sit, you'll sit together and then I'll just you'll demo to me, all right? Since we're all doing the same. We're all doing the same. Probably. Do you have the microphone on?
Yep, sorry.
So you'll do the demo the week of April 26th to the 28th. As I said, we've discussed that. You'll show Hadoop, how it works, and you need to run a job on it, right? And show evidence that I have a few set of questions that I usually ask you to show me that prove to me that you've configured the cluster correctly in Linux. Okay, so that's the week, and that's Project A. Project B is, if you don't remember, it's pretty easy. Also 5% of your grade. Pick a topic in sysadmin. If you forget this, remember I gave the example. I can't configure every single service on the course. I just can't, right? So this is your opportunity to look at other services. So in the past, students have done, for instance, they want to configure an email server on Linux, right? So they want to make their Linux machine an email server. So just like you configure DNS or you configure other things, here you get to configure email. But as always, you need to show evidence that it works, right? So you need to do a demo, send an email somehow. It doesn't have to be very complex. Also, you don't have to do scripting, right? Scripting is not a requirement, although you can also. Some students like that, and then they write some scripts related to sysadmin. Others don't want to do that, and they just configure something on Linux. Makes sense? It's got to be Linux, though. Don't come here with something with Windows, because unfortunately, that's not going to be a valid thing. This is a Linux course. All right, let me sharing the screen and recording. All right, so that's the week of the 26th, probably on April 29th, this last week, kind of like a wrap up week. I'll probably introduce Docker, which is an interesting tool. Notice you'll have a final exam, which is comprehensive, and you will also have a second exam. I usually have this exam on April 5th, but I'll be out of town on business, and so I need, on this day you'll have the exam. So I've just moved the exam from here to here. It'll be the same format as exam 1. Make sense? Questions about that? All right. And then we have just really, if you look, besides Docker, which is something we gotta look at, there's really just this sequence, right, of topics that we have left. Okay, so today I will cover SNMP. It's a very nice network management protocol that has existed for a long time. A lot of the time now, what people do is they want to sell this as a product, right? It kind of makes sense that if you're a sysadmin at a company and you're monitoring your network, that's what you do, right? And so if you do that as part of your work, it's an incentive for companies to try to sell you a product. But we're not going to look at any specific products here, and instead we're just going to look at the traditional protocol that has been used, and really honestly, upon which all of these tools are built on. Really what the vendors will try to sell you is some kind of reporting system, right? So they've written a lot of interesting reports based on SNMP, and then you can view things. And so we're going to explore that, those ideas in this lecture. There's a very nice lab, I would say. Very little scripting in this. I will, just for kind of to show you, I'll do a script maybe. But really, this is a configuration lab where you're going to configure the SNMP protocol in Linux in your 2004 VM, and a tool called Cacti. So it's actually two things, right? The SNMP service, and then the tool Cacti, which is a well-known, well-established, open source tool for monitoring. And I think you'll like it. Certainly, it'll open up your eyes to this. It's basically, you can make all these computers SNMP agents, and then you have, let's say this laptop is the Snmp Manager, so I can basically pull all the machines, get their data, and also visualize it in a web page really nicely. All right, and so that's kind of the intuition. So you'll have a couple of problems where you have to collect data. I will say this now: to collect the data, you need to run the SNMP service for a while. Don't just expect that you ran it 5 minutes and you have no data and you say it doesn't work. Well, it takes a while to collect the data. So usually in the past, students take an hour, 2 hours, just leave it, just start it up, leave it, and then come back in a couple of hours. And then you'll see that there should be something in there. After that, SNMP, I'm not entirely sure how long it'll take. It could be a couple of weeks, a week and a half at most, or maybe we'll do it in a week. That's also a possibility. After that, we just have two topics: the file system analysis, and this is like almost a forensics, but not a forensics thing, right? So the file system is very much connected to forensics, right? Because that's where data is stored. So it's not such a difficult lab, I think, but we'll see about this one. And then, but I'll definitely cover it in the lecture. And then finally, security through the use, if we're looking at Linux, obviously, just like you're familiar with your Windows firewall, there is, of course, on this Linux machine, a firewall as well. These are called host firewalls. And so this will be also a topic that we will cover. So these are the three main topics, as you can see. After that, there might be a few miscellaneous here and there things that I do, some more scripting examples, and then basically the Docker concept. All right, and that's the semester for you. Okay, make sure, as always, that you read through the materials on Brightspace. Okay, make sure that you're going through that, given that there's always some reading assignment there related to just sysat. It's more like just like not technical, the non-technical aspects, more managerial aspects of sysadmin, like managing people, things like that. So make sure you're reading through, doing all that. You don't have to read the book, just reading through the slides, that I kind of created there should be more than enough. Are there any questions, I guess? So this is, I usually like to do the calendar just so that you know what's coming up. Are there any questions about the schedule at all? About the exams, the dates, or anything like that? No questions or issues? Nope. It's in the calendar. You can just look it up. Right there. It's updated. It'll be April 12th. Got it? So I'll schedule for my classes all exams this week. That week. Okay. Anything else? Nope. All right. The other thing. Okay. There's something in the chat. No. So this question. So I assume this question relates to the map reduce scripts that we did, right? The Q lab, that example where we did the mapper and reducer Python scripts. You don't need, you wouldn't need Hadoop installed for this because that's the project, and I've explained that that's a difficult thing to have set up, right? So your project that's due at the end of the semester. For that example, you just literally have to do what I did in class, but the idea was that instead of using that text that I provided, you would do what? Gutenberg, yeah. Download 2 books from the Gutenberg. Well, that will be more information and just repeat the exercise. Does that answer your question? Okay, great. All right, so that's good. The other thing is some of you had issues configuring the Nat network between 2 VMs on Virtualbox, right? So I created this video and I posted it on YouTube. And some of you said that helped you out to complete the assignment, right? So you were all able, no issues with this? No questions about it? All right, so great. So that's the link. Okay, it worked for, yeah, great. So exactly. All right, and that actually, it's very important because that can help you out with all the other tasks that you have, and not just in this course really, but in any other course where you will be using Virtualbox and 2 networked computers, okay, for attacks, defense, etc. Actually, the SNMP lab also, as I'll start discussing in a second, involves at least 2 machines, right? So same idea. So everything, if you notice, the theme in the semester has almost been like the first half was pretty much just 1 machine. Second half now, a lot of the time, we have at least 2 or more VMs interacting. So it's more of a networked environment. Okay, but just take a look at the video if you haven't done so. I usually put links here of things that are needed. All right, are there any questions before we get started? Nope. All right, so it seems like everyone's clear. So let me just open up Brightspace. And I have some slides there. So today we're covering SNMP. So then I'm going to need those slides. All right, so we're going to go to 372. And we're going to go to content. And you can see here, I've already laid out also the material. So we are basically here. As you can see, these 3. I may have some additional, but yeah, we're not going to do this. It's too much coding for this one. And Case Aurora. We'll see. It's actually interesting. I think this is the geolocate So it's actually an interesting problem. We may do it, actually. But we have these three modules, which are the ones that I indicated are basically what's left in the semester. Host-based firewalls, right? If you're reading assignments, the file system analysis, which touches a little bit on forensics, a little bit. And then in particular today, Snmp, okay? So I'll start just to kind of motivate, as I usually like to do, with the lab itself, just to kind of, so that you know what it is that you're going to have to work on this week on Thursday. And then after that, we're just going to jump into the theory of SNMP and just kind of understanding how that works. It's actually pretty nice tool. And I'm, if you work in sysadmin, it's certainly going to be something that's going to be there for sure, right? Remember, the whole point of this class has been, beyond teaching you Linux and making you comfortable with Linux, has been automation, right? You got to do all these tasks for computers, and you want to be efficient about it, right? And also, you want to monitor your systems, right? So you want to have that ability. So, somebody came up with this idea, well, why don't we have an actual network protocol for monitoring, right? And that's literally what this is, SNMP. And so it's a protocol just like the web, right? So the great thing about the web protocol is what? That it works, you just need a browser on any computer, and it could be Mac, Linux, Windows, servers, all kinds of computers, right? And you can basically interact with that protocol. That's the idea. Phones, right? Your mobile phones, etc. Well, then the same idea came up with monitoring the network. So now you have even more things, right? Because you have printers, right? There's a printer over there, and then you have maybe this thing is connected to the network. I don't know, right? And then all these computers and whatever that thing is over there. And there's also like servers, but that's not all of it, right? There's also the networking equipment. So there's routers and switches and all the devices, the firewalls, and so Cisco, all the different firmwares, right? But you want to, in theory, you want to be able to monitor all devices. So then you come up with a protocol. They all speak this protocol, SNMP, and then now you can monitor all the devices. So that's really what we're going to discuss today in the lecture. Okay. All right, so let's go back. All right, so let's start with, as I said, with the motivation of the homework assignment itself. Okay. So the SNMP stands for the Simple Network Management Protocol. Disregard the week. I think we are actually on week 10, but that varies. Wherever you see a reference to 1204, that just means whatever the latest version of VM is, right? So I'd have to change this document every year. So it's just use 2004. Basically and I'll explain the theory, of course, but as I've usually done here, I just provide a list of bullets, numbers of the steps that you have to follow. Should be pretty straightforward. You will need 2 machines for this. Okay, you will need, just like you did in the previous DNS lab, probably seed and then clone of seed. Just have those 2 machines, make sure you can ping, all that stuff. Make sure you have a network. So you're going to configure an agent. Now, if you decide, because you want to test this out even more, you can have multiple machines. The whole point, you could have 10 agents, right? You can have 10 agents, and then all being monitored by one single computer, okay? This is very important, in an organization. This will definitely save you a lot of time. Now, this is usually this operation is usually housed in a place called the Network Operations Center, okay, which is usually in short, the NOC Center, right? So that's basically what you can imagine the NOC to be, is just basically a place where you have a whole bunch of screens, right? So you might imagine this whole room full of computer screens, right? Big screens. and each one just has a web application kind of open in there. So that's why the geolocate assignment, if we do that one, or at least as a demo, that, you know, basically geolocate means what? You have a map of the world, right? A map of the world, and you can put on that map, you know, little like lights that show where all your network traffic is coming and going. So that's pretty straightforward for your organization. You've been using PCAP files, and you've been using Wireshark all semester. So you know you can collect the data. And then now that data that's being collected almost in real time, you can just process it a little bit with a cron script and Python script every night, and then have some data in the morning of where your network is going, right? So why is your network traffic going to Russia, you know, at 3 a.m. every morning? That's probably not if you don't do business with Russia, right? So maybe you have, what could that be an indication of? Yeah, compromise, right? Somebody has installed some kind of a Trojan or something in your computers, and it's sending data to Russia. That's a very good way of detecting that, right? So immediately you find those IPs, you block them on your firewall, problem solved. You guys see that? So that's part of this, of the Network Operations Center. That's not necessarily part of SNMP itself, but it's part of that whole philosophy of monitoring your network. Now, I should say this is not just done for security, but it's just doing for performance, right? You know, assurance, you know, is not just about, you know, hacking and things like that. It's also about just quality and things actually working as they should be working. Okay, so you're going to be monitoring. And SNMP, although it has aspects of security, it's very much, as we will discuss today in the slides, not really so much about that. All right, anyway, I'm not going to read through every step. Obviously, this is what you have to do. But basically, you would have the agent, right? And you're going to configure each agent. Remember, in Linux, you configure things on text files. All right, here, basically, you're establishing the rules for access control in the designated file, right? So you're going to create, these are groups that you're creating. You're assigning those groups to individual entities, right? And then, so the groups have permissions, right? So very much like the philosophy of Linux, you have a group, you've got permissions, you add things into that group, and then the entities into that group, and then those entities represent things, like they might represent the local machine, or it might represent an IP range, right? So in this case, this would mean that these are all the computers that are allowed to access SNMP, for instance, right? So all the SNMP devices. This, I usually like to point out, this word here, public, it's sometimes confusing. That's actually a password, okay? So basically that means that, yeah, it's a clear text password. As we will see, one of the things about SNMP, it's not very focused on security, yes. So it's not very focused on that, but we'll explore that idea as well. Usually the idea, though, is because you have a separate management network, and most of the, whenever you're doing anything with management, it's in that separate network. So, you know, that provides some of it. But as we will discuss, we'll see some of those issues. But just be aware, more of a, from a, if you get stuck with the lab point of view, I just want to point out, this is the password, public, okay? So if you change this, some students in the past changed this, and then they don't understand that that's the password. So everything needs to be consistent with that. Okay, but also remember, it's not just knowing the password, the IP has also has to match. So if you want to manage a computer, you need to be in this, have this network ID basically of 192.168.189. All right, so that's one of the configurations. None of this exists in the file, so you'll have to create it. And then notice also another thing before I forget, when you open this file, basically what you should do, as it says here somewhere, is you need to comment out everything. So you literally comment out everything except the things that are not commented in these screenshots. Does that make sense? All right, good. So just make sure, you know, like you can see here, notice here, one item is not commented, etc. And then, so you'll do this, you can run nmap just to take a look at what's going on. The service for SNMP is SNMPD. You know, the D for daemon, as we've learned previously. If you want to get fancy with your network IDs, you can also use the IP calculator. That can help you to do calculations. I will do one script, but I'll do this probably on Thursday, just to show you that you can write a Python. So if we have a machine, let's say that machine is an SNMP agent, and I want to collect some data from it, I could just write a Python script and get the data, right? And then I can do my own, through cron, et cetera, my own type of analysis, okay? But otherwise, we can just use a tool like Cacti, which doesn't require any scripting to be written. You just have to do the configuration. So we would have a Cacti, let's say this computer has the Cacti server, and then you're all like sysadmins, and then we display the website on that screen. But what the Snmp manager is doing is it's getting information from all the Snmp agents, basically, okay? So that's one way, but as I said, I'm gonna show an example where we do a script, all right? And with the script, we're gonna collect data. Once you've configured the agents, you will also have to configure the manager. So the Snmp manager is the computer that basically collects the data and views it, right? So this is, that's the way this works. So you'll follow this configuration as well. This requires a little bit more. It's a little bit more involved because you're going to have to install something, as I said, you're going to have to install Cacti. Be mindful of all the passwords that you have to enter there. Probably just use the same one. I mean, it doesn't have to be super secure for this lab. And then once you have your application running, your your graphs will look like this. So what this represents is this is for the specific machine, local host. This is memory usage. So over time, right, it's going to show you the amount in kilobytes, basically, that was used over time. So you can see here how, week by week, you could see, hey, it's interesting that memory usage goes up always on Wednesdays, right? Which kind of makes sense. People come in on Monday, Tuesday, it's kind of light. By Friday, it's kind of light, but their work is, Tuesday, Wednesday, and Thursday. And so you would see that kind of information. So that's basically the idea. All right, so you'll follow these steps for the configuration. There's nothing, Cacti is not terribly difficult, so I don't remember anything that students get stuck with there. But you will just configure it, and like I said, you will create some graphs. And that's really the assignment. The assignment is, as I said, pick a few variables such as memory usage, etc., and collect some data about it, over a 2-hour period when you're doing this assignment. And then I need to see these graphs. So if you just give me the graph, but without data, you're going to lose a lot of points. All right, I'm looking for you to have actually collected the data. And the trick is just to let it run a little bit. Okay, and then that's basically the configuration for that. And then you can see here, the problems for students are simple. Add some graphs for your device and describe the results. Remember, you should have two machines, the manager and the agent. Now, the manager can also be an agent. So you literally can have two machines sending data, right? But only one of them will be a manager. Do you guys see that? All right. So add some graphs for your device and describe the results. For the selected device, and these are the instructions. Find the link, create graphs for this host, and then show screenshots. The collection of data, for the graphs can take some time. Now you can consider adding other devices, maybe your Windows physical machine, right? You can connect it to the Nat Network and install SNMP. That's up to you, though. I'm not asking you to do that. Some students in the past, though, have also tried to do with Windows or some other VM, and just to see that the protocol supports more devices. But for me, as long as you do it with seed and clone of seed, that should be it. Questions about the lab? As you can see, it's pretty straightforward, and this will be the focus of your assignment work on Thursday. And I will also probably do the scripting example. So I think there's a little bit of text here. on the script. Yeah. So we'll have to install some library Pi Snmp probably. We'll need a couple of tools there to install Pi Snmp. A pip install could very likely install it as well. All right, and yeah, that's basically it. We're going to learn about this command today, to the Snmp Walk. Once you have installed Snmp on your device, you have the daemon, and then that daemon has associated with it some commands. So there's one in particular, Snmp Walk. It's basically this. So you specify the version that you have installed, and then you specify the machine that you want to walk. So it doesn't have to be your local machine. It can be another one, right? As long as that machine allows you to be a manager in the configuration. So you have the network ID, and then notice here, -c public is what I said, the password. That C actually stands for community string. That was the name that they gave it, but it's basically a password. Got it? All right, so that will be the lab for this week, all the details of it. And now I think we are ready to just take a look at the slides, the lecture slides. Let's go ahead. I'm not seeing any questions here. The virtual environment. Now, I think in the past, one of the versions of Windows Server, I don't remember which one, 2018 maybe, let's say, had disabled SNMP, had almost said SNMP is no longer a thing, right? And you have to be careful when you see those things, because Windows Server, as I said, they sell you Windows Server, right? And you pay for it, let's say. But then if they give you SNMP in it, then they're already losing money, right? So what has happened now in the past is you got to watch out for those things. Is that companies, even Microsoft, will say, no, that's obsolete and we have a new thing. But, and by the way, you have to pay for it. And by the way, you have to pay a license for it. And by the way, how many employees, and it's that scaling up. So you got to be a little bit careful with that. But if you dig deep into what that is, you'll see it's built on top of the protocol SNMP, which was created, as we'll see, many years ago. And you'll see how the idea works. You understand? All right. So that's an important thing to be aware of. So let's open up the slides. So I'm going to need to download these. All right, here we go. So, all right, so this is SNMP. It stands for the Simple Network Management Protocol. Okay. It's there's. I'm sorry. I'm sharing the wrong screen. Oh, thank you. All right, so this is everyone in Zoom should be seeing now the slides. So Simple Network Management Protocol. As you can see, as I said, it's a protocol because they want it to work on everything, on Cisco devices, on all kinds of devices. It should be simple. And it's basically for the purpose of, now notice the word is not monitoring, but actually management. And the reason for that is SNMP supports not only reading data from a device, but writing to the device. However, the general recommendation for a very long period of time has been to disable the feature of writing to a computer with SNMP. For one thing, SNMP is a little bit insecure. And for another thing, it's got a lot of power. If you enable that feature, I mean, you can literally change any variable of that computer, and that's a very dangerous thing. You guys see that? Is that clear? So that's the basic idea. We will, as you will see in some of the information, you'll see that you have read permissions, but you also have write permissions. Now, a computer can actually have tons of variables about different things, as we will see. And so there's got to be different ways to handle all of that. And actually, SNMP is it's really a sets of data structures and sets of different languages that all work together to be able to talk to a computer. It's also supposed to be extensible in the sense that if you create a new piece of hardware, right, that piece of hardware, you know, should support SNMP, and then you need a template of the types of variables that are there, and those are called MIVs, which we will see in a second. So what is network management? So the basic tasks that fall under this category include configuration management, right? Now remember, we're just talking about this really from the point of view of Linux, so I'm not going to get into the Windows tools, etc. So configuration management, so keep track of device settings and how they function, okay? Keeping track of device settings and how they function. Fault management, so dealing with problems and emergencies in the network, such as the router stops, routing, servers, loss of power, etc. Right? So you want all this information. So this is basically what we're talking about here, has to do with kind of initially the problems, right? So forget about that SNMP has been created, or any protocol for that matter, or tool that they're selling to you. Just these are the problems that we want to deal with, right? So configuration management in some way, fault management, dealing with problems and emergencies in the network. Performance management is a big one for SNMP, which is basically looking at data, right? So how smoothly is the network running? Notice that the very first week of this lab, we kind of looked at things like this, right? We looked at uptime, and we looked at certain variables that gave us information about performance. You know, if you remember, that initial script was performance gathering metrics, right? Something like that. And so the goal of that was to get information about the local machine. Well, now this is basically that same script, but, you know, much bigger, right? So now it's not just for that local machine, but for an entire network. How do you even approach that problem? Okay. So how can it handle workload it currently has? So, you know, how do you answer these questions? Well, you need to monitor the performance of your devices. Okay. And so that's kind of the intuition there. So the functional areas of network management. So configuration management. So having an inventory, what are the configurations of the machines? Could you get all that? Fault management, reactive and proactive network fault management, performance management, number of packets dropped, timeouts, collisions. You know, as we saw in one of the previous slides, just amount of RAM used, I think it was. Security management, this would be, obviously security is important. However, SNMP doesn't provide much here. SNMP is not a security focused protocol. It's more of a monitoring, you know, performance statistics protocol. Accounting management, this is also helpful because it, you know, by keeping track of utilization of computers, et cetera, you can keep track of costs, right? You know, what departments in my organization are actually using a lot of my servers, right? And then you can allocate, well, then they need to pay a little bit more, et cetera. Asset management, so you want statistics about equipment, facility, and administration personnel. This is important because having statistics about equipment allows you to then go to management and, you know, ask for money or know how much something is worth, the value of it, et cetera. Planning with management kind of goes together here. Analysis of trends to help justify a network upgrade or bandwidth increase, right? So you can monitor all these things where you can say, well, this is how much we're using and this is how much we have. So we're getting very close to that boundary, right, of traffic, et cetera. And so you can talk to the cost centers in your organization to get more money and upgrade the equipment. So all of this, as you might imagine, are probably thought about before, are things that you would be responsible for as managing an IT practice. So you need to be able to get some data to back up your request or your recommendations, et cetera. Okay. And so that's where a protocol like SNMP, you know, whether you buy a tool for it or or you install an open source would be very helpful. So what is SNMP? So SNMP is a tool, basically a protocol that allows for remote and local management of items on the network, including servers, workstations, routers, switches, and other managed devices. As we saw in the lab, basically, we have these two concepts. We have agents and we have managers. So pretty much any device that has SNMPD on it, the daemon is now an agent, right? So you just configure it, and then you're going to have a couple of management computers that will do the monitoring of the network. So agents process is basically a process running on each managed node, collecting information about the device it is running on. And then the manager is process running on a management workstation that requests information about devices on the network itself. Okay. Advantages of using SNMP, something like SNMP is obviously if it's open source, it's free, it's standardized, universally supported, extendable. Remember, if you add new devices, etc., it needs to be able to support them. Portable, allow for distributed management access, and it should be a lightweight protocol. SNMP exposes management data. Basically, how do you get the data here? So the way that you have it is everything is a variable. So this actually is a little bit, in a sense, like what we saw in Hadoop, right? In Hadoop, we took all the words and we created them into key value pairs, right? You remember that same idea? Well, here it's kind of the same thing. We now have these entities, right, which are going to be variables. These variables have IDs, basically. So let's say that computer is a Windows 2011, or what is it? 11, right? Not 20. Windows 11. So then that computer, Windows 11, there is a data structure for Windows 11 for SNMP that says that there's, I'm just making this up, 8,000 variables associated with that system. So now each one of those 8,000 variables is one of these things, variables on the managed systems that I can query. So I can go in and say, ID so-and-so of this, I want to know the answer for it. And it's gonna report back to me that it is a, let's say it's RAM utilization, right? So it's going to give me the RAM utilization. Do you guys understand? So everything is treated as a variable. And then we're going to see that there's actually a hierarchical structure in the way that things are organized. There is a root domain for SNMP that is in charge of making sure that every variable is organized properly within this tree, right? And this tree starts at a root, and then it breaks up into all the branches for all the different devices. So there is consistency. So you have variables on the managed systems and these variables have an ID basically, and also a description of what they are, plus the value itself and some other things. These variables can be queried and sometimes set, right? Although, as I said, this would not be recommended, and nothing that we will do in the lab this semester for SNMP would require you to set them. I think in the past, some students have done this, and you can certainly do it. I mean, a lot of people do this as a practice, but through a more secure means is basically the recommendation. So if you're, you need to make sure that things are encrypted, and things like that. Maybe using a VPN might actually be a good solution, right? So if you're going to use something like that, VPN into things, etc. All right, so the overview and basic concepts. SNMP agents show data of interest on the managed system. Variables such as, and these are just examples. I mean, there can literally be 10,000 variables to one single computer, right? To one Windows 11, so there is no necessarily a limit, etc. So SNMP agents show data of interest on the managed system. Variables such as, free memory, what is the system name, number of running processes, default route. And as you can see, anything that you can configure, that's the whole idea, that you can also query as a variable and monitor over time. Okay, so that's the basic idea. So variables accessible via SNMP are, as I said, are organized in hierarchies. Okay, that's a very important thing. There's a very good organization. There's a root number, let's say 1, and then by using dots, you're going to break up into all the different branches that are available. So these hierarchies and other metadata are described by something called the MIB. And these are, in a sense, like separate from SNMP. So SNMP is a protocol, and it's got defines the rules of the network communication, etc. And then it just says, and by the way, for you to be able to query variables, you have to make sure that your variables conform to this, to the MIB, right? So, which is called the management information basis. And these are hierarchies and other metadata that describe a template of variables for a specific machine. Is this clear, guys? Making sense? All right. And there can be a lot of information for each variable, but in essence, type and description. Now, a lot of this you don't have to, you will not implement, right? So this is more just for your information, for you to understand how SNMP works. You will not be creating, let's say, a new template or anything like that. But let's say you're a hardware company, and I can't think, an Internet of Things company, right? You make up cameras, right, for CCTV, something like that. So these are network. Now you want those cameras also. It makes sense that the IT group might actually want to monitor these cameras, right, for whatever reason. And so then it is upon you to install on your cameras, they're probably running on some kind of light kernel Linux-like firmware, right? And so you want to install something like an SNMP protocol just for the communication. But then you also, when people want to monitor these cameras from their manager computer, they will need something, right? They'll need to say, okay, I need to manage that camera. I know the IP of it, but I need the MIB for that camera. So that's the data structure that defines the metadata of the variables that you can query from that camera. Do you guys see that? And so that's something that that hardware company for CCTV cameras would have to create. They would have to create this MIB and make it available to others. Okay. All right, so SNMP, in its most basic form, it's pretty simple. It's a packet, right? So it's basically a communication of single packets. So a packet here is sent to a network device, such as a router, with a question called a get. So this is a get packet, right? And it's going to have, like a query for a specific variable. So for example, one might ask, what is the value of this, right? And here, this means interface, MIB, interface out octets, right? So it's looking for that specific variable. It's saying for an interface, I want to look at all the octets, right, that were sent out, right? So, like saying all the bytes that were sent out. Also notice here that it's got a 1, indicating that it's the first interface, as you may have multiple interfaces on that device, right? So it indicates that particular device. This could be for if you have a CPU, right? And you have multiple CPUs. Or you have on your motherboard a couple of GPUs. So then you specify, I want, this GPU or that GPU. But anyway, this is the description, as you can see, of just one specific variable, okay? Now, obviously, it would be very tedious to have to make a query for every one of the 8,000 variables. As you will see in the Cacti lab, you don't have to do that, right? In the Cacti lab, you will actually just set a template. And I'm going to say this template, and then I can pick a few graphs here and there, but you don't have to. It's very GUI oriented. Now, in the Python script that we will do, it's a little bit different because there we will have to specify specifically some of the variables. So if I give you a problem, it'll probably relate to that, right? So I'll just say, I won't give you the actual variable names. I'll just say, you know, query a couple of things, and then you'll have to figure it out a little bit. But we'll go over that at some point. I have some notes. So as you can see here in the description, this just says that this variable here, this one, is in the group of interfaces. And we all know our computers have interfaces. We deal with that all the time. The router then, as part of the process, because you sent out a query, right? You know, a get query, then the router receives that query, and now it's going to reply, basically. So the router replies with a packet containing the value. Now, keep in mind, since we're talking about a service running on Linux, we're going to have port numbers associated with these. We'll talk about those in a second, but that's, you know, an important concept to be aware of. Okay. And as you know, this is more eloquent than I have been so far in saying there are variables for just about everything, right? And every kind of technology. So this, you know, IoT, right? Internet of Things. I think the example of the CCTV camera should be a good one, right? So you can imagine that's something that you probably want to monitor in your network, and you know, so everything could be potentially and variables for just about everything. So it's pretty efficient that way. I've already shown you guys how you query variables of your local host via Python, right? So you've done that quite a few times. Now just imagine, so how does the SNMPD do it? Well, SNMPD is what? Is a daemon. And what is a daemon? It's just a process running on your machine in the background. So it's literally just what? Probably C++ code, right? Kind of running in the background, probably at the kernel level. So it is really fast and efficient, okay? So the SNMP overview, you define mechanism. Sorry, the SNMP overview is that the SNMP protocol defines mechanisms for the remote management of network devices, right? You know, all kinds of devices here that you can think of, all right? And not just, by the way, routers and networking equipment, but any computer really, as you will test with Linux itself. The fundamental principle is that all device management is done by simple variable value manipulation. Okay, and that's the basic idea, and that's actually how a lot of things are done in the background, Active Directory included. All of them, you know, are just simple variable value manipulation, key value pairs. The approach is a standard means of specifying quantities recognized by devices, and SNMP basically provides this. And it's actually not very complex. I think there's just like 4 or 5 tasks, right? Commands, if you will, to better understand it. But you have a protocol for requesting, returning, and notifying changes to values, okay? So that's the basic idea. So here's a nice graph that shows, you can imagine here you have a network, right? And a computer running as a management software with GUI. So this is the SNMP management station. So this is your Linux or your Mac, right, computer. And you've got SNMP install on it. And you have Cacti, which is the tool that you will use in the lab. Cacti is open source. Pretty much all the books on this kind of work, automated sysadmin, show Cacti, right? It's been a tool for quite a while as an open source tool. It may not have everything that a vendor will try to sell you, as I said, in particular, the reporting features and so on. But you can write those reports, right? That's why I'm actually going to show you the Python script, just to show you that I'll do a very basic thing, but just by showing you that pipeline, you should be able to understand that you can query just about anything. In the past, some students, if you're looking for a term project idea, some students have actually done this. They decided to just install SNMP on several devices, but they wrote, instead of using Cacti, they wrote all the scripts themselves. So they wrote like a Python scripts, etc., to collect the data, and that way they could sell reports and so on. So here in this scenario, this is a network, and you can see here we have, you know, a router, a bridge, a printer, a local machine, and what's important about them is that they all have the SNMP agent installed on them, right? Which is, you know, I've already shown you. I think it's like apt install SNMP that pretty much does it, and then you have, you know, you just. Now, the key thing, though, this is what I want you to, what I want to explain a little bit, is that imagine that this computer is 205.215.116.11, right? So if you remember in the lab, there was an access control section. In that access control section, it said, this is an agent, this is a manager. So keep that in mind. So this is a manager. And so when you configure this device over here, you have to say, by the way, my network, my management network, if you will, is 205. Oops, it's not gonna be. I don't even write. That doesn't work. Okay, I'm just gonna scratch. All right, so my network is 205.215.116-024, right? So if you remember that, I think this is actually, that was the entry in the lab. What that implies is only computers from this network can manage this agent. You guys see that? So that's why this computer would be able to query this other computer, because it is 205.215.116.11, and that's in this network over here. But if this computer was, let's say, you know, 192.168.1.6, the agent would look at that IP, would look at this IP, and it would not let it speak to it. Plus, the community string also needs to be sent in there, which, remember, in all the screenshots, it is just the word public, and it's usually, that's the one. Does this make sense? Any questions about that? Pretty easy, right? This is probably the hardest thing that you'll have to do in the lab, right? So making sure that you get this right. That's about where I see where students have gotten confused in the past. So hopefully this made sense. And then the other thing is just selecting like templates. That just takes a little bit of time. All right, so I'm gonna move on. All right, so SNMP, here's an example. So this is now on Linux, on your Linux VM. This is actually one of the things that you will have to do. This assumes that you've already installed, you know, SNMP on an agent and a manager, right? Or it could be just on the same machine, right? So once you install SNMP, that machine can be a manager and can be an agent. So then what you do is, notice here, you have the prompt. You'll have to watch out for the fact if you need sudo. I don't believe you need sudo, but, and by looking at this, it tells me that it's not needed, but just, you know, be aware of that. So you do what is called an Snmp walk. And an Snmp walk is a really nice command that basically says, I'm gonna query this machine and I'm gonna walk it. So what that means is if it's got 8,000 variables, I'm gonna see all 8,000 variables. So all of them get printed out on the terminal, okay? So in this case, notice the syntax, Snmp walk -c public, right? That's the community string. The version usually, I think is usually version 2C or something. You'll have to look at the tutorial. And then here, this is just the domain name, right? So it uses DNS resolution to look at it, but it could also be an IP address, or if you're just doing it on your local machine, it could be localhost, or it could be 127, you know, .0, so on. And once you run the command, this is going to be your output. So your output will be all of this. So as you can see, it just starts printing out variables. Okay, so here's the first variable, this one, SNMP version 2, MIB system description. Notice that it actually gives you the text and not the OIDs. The OIDs are the actual numeric representation, hierarchical numeric representation of this. But this just gives you the actual description. And then notice it gives you also the value of it, right? So it gives you the value of your machine. So if you go ahead and, if you right now, if you have your VM, for instance, you could easily just go install SNMP on it, do the Snmp walk on your local host, and you should be able to walk it already. Does that make sense? So we'll try that in a second, but that's basically the idea. Then it starts to print out. So this is all the information. So this is a string, HP, Ethernet, multi-environment, jet direct. It makes me think this is some kind of a printer or something. And then over here, it prints out another variable, which says SNMP version 2 MIB system object ID. And then you can see where it's kind of mapped, right? And then after that, it starts to do things like, for instance, here's our famous system uptime, right? And so it tells you how long, just like, as I said before, right, at the very beginning of the semester, your first assignment probably was the system gathering script. And what you had to do is collect uptime, right? Well, now you're collecting uptime, but you're connecting it or collecting it in a much more distributed fashion, right? And so we need this idea. So this will provide, the number of days, right? There it is, 32 days, et cetera, that the system has been up. Got it? Pretty straightforward, right? All right, good. So let's just dig a little bit deeper into some of these aspects. So we've got nodes. And that's the language of SNMP. So nodes are items in an SNMP network are called nodes. There are different types of nodes. So we've got managed nodes, right? And we've got management nodes. And then we have nodes that are not manageable by SNMP. So maybe some legacy computers, et cetera, that just don't support the protocol for whatever reason. Typically runs an agent process that services requests from a management node. And then you have, typically the management node is a workstation running some network management and monitoring software like Cacti. And nodes can be both managed nodes and management nodes at the same time. So you will actually get to see that in the lab. Here's an example. You've got some agents on the routers, on the servers, and then you have a couple of laptops that run the Cacti software, which is the manager for our particular scenario this week. And so, as long as the data, as long as you can ping, right, it's going to work because you just send the packets across the network. A proxy and gateway agents, these are just whenever you want to reach a machine that doesn't speak SNMP, you'll have to do some workarounds to get that to work. So that's basically the idea there. Now, these are important. So what are the 4 basic operations for SNMP? So we've got, these basic ones, 1, 2, 3, 4. All right, so we've got the get request basically, which is, the idea that you're going to query the machine. So retrieves the value of a MIB variable stored on the agent machine. And this can be either an integer, a string, address, or another MIB variable. All right. So we've got the get request. retrieves value of MIB variable stored. Then we have get next, which is basically retrieves the next value of the next lexical MIB variable. So if you want to think of this as the Snmp walk, right? So the Snmp walk needs an efficient way of just gathering all the variables. So it retrieves the next value of the next lexical MIB. Think of it as just instead of doing an inefficient for loop of gets, you have a process that's a little bit more efficient for moving around. Set, of course, as the name implies, this would mean changes the value of an MIB variable, right? So changes the value of an MIB variable. Remember, generally speaking, don't use this. Okay, try to use other tools. At the end of the day, other protocols would probably work the exact same way, but the key thing is they'll have a lot more built-in security. Okay, if you ever do this, do it through a VPN. Be very careful, and because if somebody hacks your computers and takes over something like this, I mean, you can imagine what they can do, right? A lot. Now, a trap is an interesting one. Traps are unsolicited notifications sent by the agent to a management device. Typically a notification of something unexpected, like an error. So this is very nice. So if you think about it, you're a sysadmin, right? And you're just at home, you know, it's 3 a.m. and boom, you get a text. And the text says server's down or the switch is down. So if that's your job, right, you want to know about it. Right. And so that's what that is. So the device itself is communicating to you, you know, fully automated. Right. And so it's letting you know that there's a problem. So when can this happen? Like if you have a switch with 2 cards, right, and you know, one card goes down, it lets you know. Or maybe there's another device and that device is no longer detecting that device, right? The device in question, and that device can send a trap and just inform you. Does that make sense? So it's just unsolicited. That's it. I mean, Snmp is not complicated, and it should be obvious since the word simple is in the name, right? So it's literally there. So traps are unrequested event reports that are sent to a management system by an Snmp agent. When a trappable event occurs, a trap message is generated by the agent and is sent to a trap destination, which is a specific configured network address. Many events can be configured to signal a trap, like a network cable fault, failing NIC card or hard drive, you know, a general protection fault, or a power supply failure, right? Any kind of thing. In the hardware, that's what Snmp is for, right? Remember, it's just C code, right? Running efficiently, you know, as part of that firmware, checking on the status of things. Okay, so it's checking the buffers in memory, and there's usually bits in memory that indicate the status of your hardware. Okay. Traps can also be throttled, so you can limit the number of traps that are sent from the agent, especially if you have a really large network that's kind of buggy, you know, like this one, right? Don't send this. Don't throttle me with that message of network is, or don't you know, send me too many of those. All right. So, but what's nice about it is traps have a priority associated with them, right? So that's like very much like intrusion detection systems, which also can generate a lot of data. I mean, the network, right? There's a lot of anomalies and strange things going on. So in the network also, the protocol should support a priority associated process that can indicate if it's a critical, major, minor, a warning, marginal, just informational, normal, or unknown kind of set of statuses, right? And that just tells you what kind of a trap it is and the kind of attention that you need to pay to it. So here's a nice one. Traps are received by a management application, and then the management application can handle the trap in a few ways, right? Now, the software that we have, like Cacti, does not support this, but obviously this is where vendors step in, right? and they write more applications that would be able to send you a text saying, you know, your server just blue screened at 3:46 a.m. You know, have a nice day. All right, so that's additional things that multiple apps, Spiceworks, et cetera, as a company, Spiceworks, and other companies that might develop these applications. So here we have, so let's see, what time do we have? So let's do this. So we've gone over some of the introduction, right? We still have a few things to cover, basically like the components that make up SNMP, or the different like structures. So we can see here, you know, how the model works, and a few other things that make up SNMP, right? So we will come back to these later. And right now, what we should probably try to do is, let's just see if we can't get on the VM and just start playing with SNMP a little bit. So I'll come back to this, the port numbers, et cetera. The versions of it, the historical point of view, sure is here, and then some aspects of the security. But we'll come back to that a little bit later. So start it. So let's go ahead and start the virtual machine. We're going to need probably for this the PDF of the Word document. So this is the Word document. I'm going to open it up. All right. And so this is configure an agent. So really, app install SNMP, SNMPD. So we're going to start up our virtual machine. Okay, let's go ahead and start the VM. Oops, what's that? All right, I'm just going to start a regular VM here. I'm going to share this screen. Share the screen. Okay. So it's doing something. What is this? And it's also not starting. Okay, hold on. Yes, like I don't know what happened. Oh, there we go. All right, so I'm out of here. I'm not sure why it's not starting. All right, so I don't know what. All right, so we're back. Okay, so this is the VM. Let's go ahead, log in. Okay. So we're going to log into the virtual machine. Right, there we are. Okay, so now if we go back to the document, so I'm going to share that one. Basically, it says we're going to need, I'm just going to do it for one machine. We're going to take a look at the machine, and we should install some aspects of SNMP. So I'll try to install these. And then after that, I'm going to run an SNMP walk of the machine itself, 127.0.0.1. Right, so sudo apt install snmpd. Open up a terminal, share that screen. So sudo apt install snmpd. Right. Decrease this in size. Slowed down a bit. Well, there it goes. Let's give it a minute. Are you guys also running this command? Is it taking a long time or is it already done? Not sure what happened. Okay. All right, so it's finished. And then I'm going to do the other one, Snmp. All right, we'll give it a second there. And basically, once we do that, then you would do the other aspects of the configuration. But in particular, what I want to do is I want to do an Snmp walk, right? So Snmp walk of the local machine. So I'm going to try that command and see what happens. All right, so finish there. Now I'm going to do Snmp walk. That v2c -c public, and then you could say localhost or 127.0.0.1, and there you go. So if you notice, I just run the command snmp walk, the version, the community string by default, the local this local machine's IP, and it gives me basically information about the machine. So you can see here, we can actually corroborate the information. So this is Linux VM, Ubuntu, and the information that we have for it. Notice over here that it provides this ISO 361. And then the numbers start to change after that. This is something that we will discuss a little later, but it relates to the OIDs basically. So it relates to the hierarchical representation of these variables as IDs basically. Okay, you can see it provides information about the machine. Here we have some information about time ticks. Here we have information about who is probably the person that manages this machine. So there's some configuration file where me at example.org. So obviously in your lab, I think one of the problems is you have to change this and just put in your name and your email and then show that screenshot. Sitting on the dock of the bay, that's just a funny thing that Linux puts as related to the location of the machine by default. Okay, so this is a location-based thing. Then information about other OIDs, the management architecture, information about the MIB itself. So let's see what else. Just looking for some interface data, but I don't see it by default here. So we looked at this. Yeah, so you can get a lot more information than this. So this is just probably a very shortened version of it. As we look at some of the Python scripts, for instance, we'll be able to actually configure this, directly, right? So we will need to learn a little bit more about how OIDs are organized and map to individual variables. But that's kind of just a quick introduction of it. Does this make sense? Pretty easy, right? Obviously, you have to do a little bit more in the configuration between an agent and a manager, but at least we've shown that you can walk this individual machine. Any questions? Nope. All right, great. So let's turn off the VM then. And then we'll do some of the scripts on Thursday. I don't want to get into those today. But at least we know that we have now a machine that has an SNMP. If we can walk it, then that's a good indication that your Python script will also work, right? Because you can Snmp walk, it gives you some variables. So now the Python script should also be able to work. All right, so let's turn it off. Okay, so that's all. All right, so can go back to the slides then. So everyone should be seeing the slides. All right. So let's go back to where we were. Kind of. Oh yeah, here, right? So we talked about traps and we established those. Then management components, right? So some of the components of Snmp. So to do management tasks, Snmp uses two other protocols, right? Which are the structure of management information, SMI, and the management information base, MIB. There's a good analogy for understanding this, and it's programming languages, right? So it's going to be like a programming language. You know, you'll see in a second how these relate, Snmp, SMI, and MIB. So Snmp, you can think of it as the most hardware level part of the programming, right? So it's at the very core, and then these are like layers above it that define like the structures, and then there's like the definition of the syntax of a programming language. Do you guys see that? So you know that when you write some C code, it has to be converted to machine code. It runs in the network, or sorry, it runs in the CPU in the background. But then, you know, you use that C code to define some data structures. But then the C code itself has a set of rules on the syntax that you can use, the keywords, etc. And that's kind of what this is. Basically, it defines in a similar way how you can go about creating MIBs and using Snmp itself. So Snmp architecture and model, right? So we have covered, these are basically different ways in which you can look at Snmp. So you can look at it from the point of view of the organization of Snmp. You can look at it from just the information about Snmp. You can look at it from the communication point of view. So and from the function, right? So the remaining slides will look at Snmp in one of these different perspectives, right? So what that means is the communication, that's probably the one that talks about, oh, you use UDP packets and so on. And then the functional, that's the one that talks about, okay, what do you use Snmp for? The information, that's the one that will get a little bit more deeper into OIDs and MIBs and all of that. And then the organization model will just talk about who are the agents, who are the managers, etc. Do you guys see that? So that's really all that this is. It's not really that big of a deal. All right, but let's leave that for, so we've covered a lot today in the lecture. Let's leave the rest of this for next week. Okay, so the plan now, what we are going to do for Thursday is, as I said, if I go back to the Word document here. So on Thursday, we're just going to meet. I've already demoed a quick way of just getting Snmp running, doing an Snmp walk. I suggest if you didn't do that today, that you do that first thing on Thursday. And then after that, you're going to follow the instructions here, configure your Snmp agent. See here now, you probably understand what this is a little bit better, right? Notice that you only have read permissions, right? And write permissions are turned to off or none, sorry. So you'll do this configuration for your device, right? And then I will do the script. So we will install a few additional libraries on Thursday, and then I'll provide one or two scripts. Yeah, and then you will have to configure the manager, have two devices in your network, and then finally just start collecting these graphs. Does this make sense? Questions? All right, so I'll stay a few minutes if you have any questions about anything. Otherwise, I will see you guys on Thursday, and I'm going to go ahead and turn off the recording.